Okay, so we are starting on unit 6.1. Okay, and what we're going to be working on today is, it's called evaluate. We will evaluate nth, roots, nth. Okay, nth, roots, and use rational exponents. Okay, evaluate nth roots.
How about n to the th power?
Or n to the th power, okay? Nth roots is basically like any exponent number, okay? So, or excuse me, any root number. So it could be like a square root, a cube root, a fourth root, okay? That's why it's called nth, because there's not just one. Okay, and use rational exponents. What's the word rational mean? Okay. It means reasonable or logical in English. What about in math? What's the word ratio tell you? The word ratio is what? A ratio is a fraction. So does that help to tell you what we're going to do today? Fraction exponents. Okay? We call them rational exponents, but we also would call them fractional exponents. Okay? So there is a rule, a couple different rules that you need to know. When we are when we are converting, okay, between forms. Converting between forms. Okay, we are going to be converting between two different forms here. Okay, we are going to be converting between something called rational exponent notation rational exponent notation, and we're going to be converting to radical notation. Okay, and it'll make a little more sense once we get into this. Okay, so if I gave you something like a to the p over h power. Okay, a to the p over h power. Okay, the reason we put a p and an h is because this is what we would typically call the power, and this is the handle. Okay, so when you change this from a to a fractional power, this becomes, in radical notation, we would put this in parentheses, put a root. Okay, the a is underneath the root, and then when you fill things in, the p is the power. Okay, so it would go on the outside. H is the number that would go inside the handle. Okay, so we call it power over handle. So when you switch between the two, P is the power that goes on the outside, H is the handle, and we call this the handle. Okay, the little inside of the root. Okay, you also need to know to be able to go from A to the negative P over H power. Okay. If I switch that, okay, if it is a negative power, what do you first have to do if you have a negative power? Does anyone remember? Move it to the opposite side of the fraction bar. Okay, now, this is not the fraction bar that I'm talking about. What you actually have to do is this becomes a 1 over a to the positive p over h power. Okay, so when you convert that to radical notation, it would be a 1 over, then you put in your a and your power and handle. Okay, so the power is still on the outside, handle is still inside there. Okay, now, there is a limitation here. A cannot equal 0 when you have a negative there. Okay, so if you had a 0 underneath, remember 0 under, so 1 over a 0. 0 under tells you that something is undefined. Okay, so there is a little bit of a limitation there. You cannot have a equal to 0. Okay, so that's like the technical aspect of what we're doing today. Okay, what we're really going to do is evaluate. All your instructions are going to tell you to evaluate. So for number 1, if I ask you to evaluate 16 to the 3/2 power. 16 to the 3/2 power. Okay, in order for you to evaluate that, we have to switch from rational exponent notation, so basically from fraction exponents, we need to switch it to be underneath a root. Okay, so when we switch this, you put the 16 under the root, Does the 3 go on the outside or in the handle? The 3 is on the outside, so that's your power. 2 is in the handle. Okay, now, usually a square root, we never write it, but it always has a handle of 2. Okay, so this just tells you there has to be 2 identical things in order for it to get out from underneath the radical. So what is the square root of 16? 4. So really we're just going to have 4 to the 3rd power, which equals what? 64. That's your answer. Okay, so 16 to the 3/2 power is equivalent if you evaluate it to 64. Okay, let's try another one for number 2. I want you to evaluate 32 to the negative 3/5 power. 32 to the negative 3/5 power. Did you have a question, Nellie?
Yeah.
You got it. Okay. Okay, so 32 to the negative 3/5. Okay, before you can do anything, you have to make this a positive exponent. So first thing you want to do is make this 1 over 32 to the positive 3/5. Then we can evaluate. So this is 1 over, put in your 32. It's going to be to the 3rd power. Okay, remember power is on the top. And a handle of 5. Okay, so this tells you that there has to be 5 identical things to take out under here. Okay, now these are usually, they're going to be nice even numbers. So what could 32 break into? Is anything to the 5th power equal to 32? Okay, well, you can start breaking it down. So what does it break down to, Maddie? 8 and 4. Okay, we can start with 8 and 4. Then 4 breaks down to what? 2 and 2. And what does 8 break into? 4 and 2. Keep breaking it down. 2 and 4, and another 2 and 2. So to get out from underneath the handle, or out from underneath the radical, we have to have 5 identical things. And look what happens here. You have 5 2's. Okay, so really the 5th root of 32 is what? Just 2. Okay, so really this is 1 over 2 to the 3rd power, because there was still a 3 on the outside. What is 2 to the 3rd power? No, not 2 times 3. 2 to the 3rd power is 8, right? So 1 over 8. That's your answer that we're looking for. You're up here. Yes. Why is it 2? Because remember, we have to have 5 identical things to get out of here. So 32 breaks down to 2 times 2 times 2 times 2 times 2. Make sense? Okay, let's try another one. For number 3. Listen, please. Listen, please. Guys, number 3, I want you to evaluate 125 to the 2/3 power. I want you to try to set that one up. 125 to the 2/3 power. So since it's not a negative power, I want you to change it into power handle. I'm sorry. Plus, you're over there. My bad. Okay, so change this to be power handle form. So this is still your 125 goes underneath. Power of 2, handle of 3. What is the cube root of 125? 5, right, because 125 is 5 times 5 times 5. So really, we're asking you to evaluate 5 squared, and what is 5 squared? 25, right. So 125 to the 2/3 is actually 25. Okay, anyone have questions so far? Making sense-ish, hopefully? Okay, let's try another one. For number 4, okay, breakdown for number 4, I would like you to evaluate 8 to the negative 4/3. 8 to the negative 4/3. 8 to the negative 4/3. So what's my first step? Janelle, what do you think is my first step?
Make it 1 over 8.
Perfect. So make it to its positive exponent, so 1 over 8 to the 4/3. Okay, then if I change this into power handle, what number goes in the power place? What number is going to go in the power? The 4 or the 3? Jacob? The 4 goes on the outside, so that means the 3 goes in the handle. What is the cube root of 8? Does anyone know? 2. So this is 1 over 2 to the 4th power. And what is 2 to the 4th power? 16. So 1 over 16. Okay, that's your answer though. Okay. Last one, number 5. I want you to evaluate the cube root of negative 8. Cube root of negative 8. Now, do you think this is going to have anything to do with eyes?
Yes.
No. Okay? Eyes are only useful, okay? We only use eyes if it is the square root of something. But thanks for trying. You had a 50-50 shot. Okay? So eyes we only use, remember an I is the square root of negative 1 is equal to I. Okay? What we never really told you is there is actually a little 2 in there. Okay, so the square root of negative 1 equals I. This is not, we're not talking about square roots. What would you say if I just gave you, what is the cube root of positive 8? 2. Well, does it make sense that this is negative 2 times negative 2 times negative 2?
Yep.
Yeah.
Right? Because look, negative, 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 that equals a negative. Okay? So the actual cube root of negative 8 is a negative 2. Okay? So there's a couple different kind of rules that you need to know here. Okay? If you have a root that is a positive number underneath the radical and an even handle number. Okay? If you have something that's an even handle number with a positive underneath. Okay? So think of it kind of like if you had the square root of 16. What would that give you? What is the square root of 16?
4.
Is it just 4?
4.
Or is it just positive 4? Or negative 4? Okay. If you plug that back in, couldn't I get negative 4? 16 breaks down to 4 and 4, but couldn't it also be negative 4 and negative 4? Yes. Okay. So what you have to do here, hey, listen, is anytime you have an even number inside your handle and a positive underneath, your answer will be plus or minus. Okay? Your answer will be plus or minus. Okay? And then the root. Okay? So plus or minus the positive number. Okay? Well, and I'll write plus or minus the positive number. Okay? Anytime you have something that's a root, okay, that has a negative number underneath, okay, a negative number underneath with an even handle, okay? So I want you to think of something like the square root of negative 16. What would that give you? Do you know what the square root of negative 16 is? And since we learned eyes last unit, that's really great, but now we're going to not use them for this unit. So we're kind of going backwards a little bit. So this is a little bit easier because you don't have to use eyes. So is it possible to have a real number? So we're talking about real numbers now. Is there any real number that breaks down twice to give you a negative? No. So your answer here is no solution. Okay? So what you actually write here is no real numbers. Okay? You do know that it could be an imaginary number, but no real numbers.